Right, section 3 has to do with another one of our transformations. It's the dilations. When you dilate something, you either make it bigger or smaller, basically. Um, so the description of a dilation will always include the scale factor and the center of the dilation. Now, luckily for us, we're always just going to use our center as the origin, so 0, 0. Everything is dilating from the center. It's getting bigger from there. So this is kind of what a dilation might look like, or what it might mean. If we have the center here and the original one, well, everything is just getting a little bit bigger proportionally as it becomes the new dilation. Now it can also get smaller. We could put another one right here in this smaller space. That would be a dilation getting smaller. For this one, the scale factor would be bigger than 1 because you're multiplying it by a bigger number to make it bigger. If it were on this side, our dilation, the scale factor would be a fraction, something less than 1, because it's getting smaller. Now the scale factor shouldn't be negative, because you're not becoming a negative distance. It'll always just be in between 0 and infinity, technically. Anything that's less than 1 means you're getting smaller. Anything bigger than 1 means you're getting bigger. So, for example, right here, we can see that we went from these spots, A right here, B right here, and C. And if we're coming from the center at the origin right here, A was -2, -2, B was 1, -1, and C was 0, -2, or sorry, 0, +2. Well, now A prime is -4, -4. You can see, going from the center out to our original spot, it's twice as far now to the next one. So this one got dilated by a scale factor of 2. Now it kind of makes sense that if these are -2 and -2, we multiply those by our scale factor of 2, multiply by 2, we get -4, -4. Same thing, as we come out to original B, it's twice as far now out to B prime. So 1, -1, we multiply those both by 2 and we get 2, -2. Same thing going from original C and C prime. 0 and 2 become 0 and 4 because we multiplied them by 2. So this dilation meant we took the original figure, this pink triangle, and we just multiplied everything by 2. So it was a dilation with a scale factor of 2 coming from the origin. So if we have the polygon RTGH and it has vertices at -4, 1, 2, 3, 2, -1, and -4, -3. And we say that it undergoes a dilation with a scale factor of 3. What are the coordinates of the new polygon? Now that might look something like this. That would be our original figure. Well, if it's a scale factor of 3, everything is getting 3 times as big from the center. We should say then that the center was right here. So everything just moved out 3 times as far. And again, the way we can check this or show this is we just do 3 multiplied by each of our points, or each value in our point. So it's no longer -4, 1, it's -12, 3. It's no longer 2, 3, it's 6, 9. It's no longer 2, -1, it's 6, -3. And it's no longer -4, -3, it's -12, -9. So it would make a 4-sided figure. Not necessarily looks like, it doesn't necessarily look exactly like this, but if these were the points given, scale factor of 3, all of those just get multiplied by 3, and that would make our new polygon. In this example, we are asked to graph A, B, C, D with the following vertices. So A is at -6, 6. So -6, 6 is right here. We'll call it A. B is at -6, -6. So that would be down here. C would be at 6, -6. So we're over here now. Looks like we're making a big square. And D then would be at 6, 6. So yes, in fact, we did just make one big square. I'm just going to fill everything in here so we can see that this does make a square. Oops. There we go. So now we're going to perform a dilation with a scale factor of 1/3 and graph the new image. Be sure to label the coordinates of the image. So A, remember, was -6, 6, which means the next one should be at -2, 2. And what we would call that, the next point then is at -2, 2, we would call it A prime. Okay, same thing with B. We were at -6, -6. Multiply it by 1/3. 1/3 of each of those, oops, there we go, would be -2, -2. So we would be right here. And again, no longer be B, we'd call it B prime. C was at 6, -6. So 1/3 of each of those is 2, -2. Be right here. And D was at 6, 6. 1/3 of each of those would make 2, 2. So we'd be right here. Again, it's no longer D, it's D prime. So this would be our new image, our new figure. The pre-image, remember, being this red square on the outside, A, B, C, D. The image then, A prime, B prime, C prime, D prime, we got just by multiplying each of these numbers by our scale factor of 1/3, meaning it got smaller. We dilated it down smaller. So again, here would be the labels, and that would be how a dilation works. And that should actually be it for this video.